You only need 8. Or you need at least, well, you need 7. I don't know if they make 7 packs. All right, so we need to simplify this radical. There's 2 ways to do that. One way works when there's small numbers, but it doesn't really work when the numbers get bigger. All right? So this is one way to do it. I don't need to do that. I can break any square root up into the multiplication of 2 other square roots. So I can do the square root of 2 times the square root of 4. I can split that up like that if I want to. But or then I can do the square root of 4 is what? 2. And then I can't do anything with the square root of 2. But 2 times the square root of 2 is just 2 root 2. And they'd rather you write it like that. Right. Now that's easy enough when the numbers are small, but when the numbers get bigger, it's harder. So this is the other way to do it. And first of all, I want you to know that 8 can be broken up. Any 8 can be broken up into 3 2s. Alright, y'all remember doing factor trees when y'all were...
Yes.
Alright. Do what? Yep. I also have a laser pointer on this thing. I can do it with here too.
That is cool. You're so cool.
Alright. So I have 3 2s. Alright. And this is how I do it. Once you make your factor tree all the way out, since it's a square root, I want to find pairs of 2 numbers. Pairs of 2 numbers. If it was a cube root, I'd want to find sets of 3. If it was a 4th root, I'd want to find sets of 4. On this one, I just want to find pairs. So I've got 1 pair of 2s. All right. So when I pull it out, I'm only going to pull right down 1 2 on the outside of the square root. So all your answers when you're simplifying square roots, you're going to have something on the inside and something on the outside. All right. When I pull out a pair, I write it down 1 time. So I have 1 pair of 2s. So I write down 1 2 on the outside. I got 1 2 left over, so that goes on the inside. So you get the same answer. And this way, it's not that this way right here is hard. It's just when you get bigger numbers, it's harder to find the number that you need to find to take the square. It's like a laser pointer, but it's on here. So like because on the video, like if I post on the internet and I use this laser pointer, then the people watching at home can't see this. So if I say, look at this right here, they're like, I don't know what I'm talking about. But if I use this one, they can tell what I'm talking about. I would rather use the pen, but it doesn't show up on the video. Yeah. Alright, so okay. So square root of 12. Well, we can try. So y'all try the square root of 12 for just sake. I can split it up into the square root of 4 and the square root of 3. But the reason you can't do that is because I can't split up the square root of 6. I can't take the square root of 6. I got to split it up into something I can take the square root of. If I do it this way, I can't take the square root of 3. It's not a perfect square. So that would be my answer. But the easy way is just make the factor tree. 6 and 2. And then 6 breaks up into what?
So your answer is going to be something that does not break up?
Not necessarily.
Like that you can't take the root of?
Yeah, you want to. If I can take the square root of it, I want to bring it outside, and then leave what I can't take the square root of on the inside. But the easiest thing to do is to make the factor tree. So I can split 12 up. I can split 12. No, I can split 12 up into 6 times 2. And I can split 6 up into 3 times 2. Does that make sense?
That's what I was trying to do.
That's my factor tree. Then I just need a pair of something. If I don't have a pair of anything, then I can't take anything out. I got a pair of 2s. Alright, so my answer is going to have a square root somewhere in it. Have 1 pair of 2s, so 1 2 goes on the outside.
you have 1 3.
I have a 3 left over, and it goes back on the inside. So I got the same thing. That's the easiest way.
I found the other way.
I found the other way easier.
But what? Okay, well, we're going to get to bigger numbers here in a second. Though.
Okay.
Like, why do you know the 2 would be on the outside?
Because really, this is what I'm doing is breaking this up
it's
into.
a pair.
Yes, it's a pair of 2s. All right, it's got to be paired up with something else, or you can't take it on the outside. All right, so y'all try.
So once you got the first answer, what did you do to get the second one?
All right, well, what are you asking?
Like,
This one
why did you do it again?
to show you 2 different ways to do it.
Okay, well, the first one.
I know this one's easier
I
now.
thought you were like trying to reduce.
No, this one's easy. There's 2 different ways to do it. Like this is one way, and then this is another way. I don't care which way you do it.
This is easier than that. This is not rigged. I said it's easier than rigged. I did this last year.
Okay, so y'all try that one. Okay, so let's go over it. I'll do it both ways. If I split it up this way, I need to do the square root of something. When I split it up the first way, I have to find something I can take the square root of.
6 and 9.
So square root of 9, square root of 6.
I thought you could take square root of 6.
I can't, but I can take the square root of 9. And the square root of 9 is 3, so it's 3 root 6.
9 times 6? I thought it would be 5 root.
Hold on. No, you can't do your multiplication tables.
What if you did 27 times 2?
That's fine. All right, let's say let's break that up. We do 27. I can't take the square root of 27 or 2. But it's 9 and 3. I can split up 3. All right, but I need to find pairs. I have 1 pair of 3s. All right. My answer is going to have a square root. I have 1 pair of 3s, so 1 3 goes on the outside. Then I have a 3 and a 2 left over. So they both go up under there.
What did I tell you?
And I multiply them together.
I told you now.
So 6.
Anything you have left over goes underneath and you multiply it together. And there's a possibility that we could have 2 numbers on the outside, which we're about to get to. Have 2 numbers on the outside, and you got to just multiply them together. So if I have 2 pairs of something, or I have a pair of 3s and a pair of 2s, then I'd put the 3 and the 2 outside and multiply them together. Okay. I'm not gonna do it the first way because I don't know a number that goes into 8064. I can take the square root. I'm talking about that I can take the square root of off the top of my head. Okay? But let's just say I can't think of anything else but 2 that goes into it.
You know how long that's going to be? Yeah, I'm still dividing.
That's what I did.
You and 126.
How do you know these? Oh my gosh.
He's remembering them.
No, look.
No.
If it's half, actually, I'd use different numbers in the other class. Look, 4,032 divided by 2. I'm taking half of it. Madison, Brody. I can't. I'm just half of that.
No, I know what I did. I know what you're saying. Okay.
So if we break that down into that, then we just go through. This is why when it's this big, that's why I advise circling the pairs, so you can keep track. So there's 1 pair. There's 1 pair. There's 1 pair. And I've already got that wrote down, so I'm not counting. Don't count it twice. You should be able to go all the way down your paper. All right. So then here's a pair of 3s. All right. So then I've got. So here's my answer. Is going to be. I've got 1, 2, 3 pairs of 2s. So that's 2 times 2 times 2. And then 1 pair of 3s times 3. And I've got a 7 left over and a 2 left over.
I thought I was doing it right, and then I messed up.
So 3 2s is 8. Remember that times 3 is 24. Yeah, that's fine. I don't care. 24 root 14.
Did you put that thing? We don't have that big of number on anything.
Well, they're going to be a lot larger.
I don't think they're going to get any bigger than that, but there are some that are big, like around 500 or so.
Is that right?
You've got one pair, two pairs, three pairs, pair of threes. You're just missing a 7 somewhere.
It was 7 anyway. Because I didn't do it the way you did.
I know, but you should still. But it doesn't.
6 times 7 is 42.
Okay, so this is all
So the answer.
fine and good. Yeah, the answer is 24 root 14. Alright, so when we come, but now, unfortunately, we have to bring letters into it.
Really? We
Yeah.
bring letters into every math.
But actually, the letters are really easy. Alright, I want to show you. So what example am I on?
Five.
Because I got 2 different papers over here. Okay. Okay. So we're going to bring letters into it.
You scared me.
But it's really simple. Don't freak out. Yeah, let me finish, and then you can decide if you want to freak out or not. Start with the number. Can I take the square root of 81? It's what? It's 9. So square root of 81 is 9. I don't have to do anything else because I know that. All right.
So, man, I was doing the same with
You could still, but you just get 9. If you did the factor tree, you'd still get 9. All right. Now here's the easy part. If it's a square root, take all your exponents of the one with the letters, with the variables. Take your exponents and divide it by 2. All right. If it was a cube root, you divide by 3. If it was a fifth root, you divide by 5. Sixth root, 6. All right. So I'm going to take my exponent. So that's x to the third. I'm going to take the x to the third and divide it by 2. So what is
1.5.
What is 3 divided by 2? I want to know how many times it'll go in there. 1. So I've got x to the first outside. What's my remainder? 1. So I've got 1x on the inside.
Oh, yeah. Yep, I'll fail.
Alright. Okay, well what's y divided?
It's going to make 9xy root x.
Y is squared. Because 2 will go into 4 2 times. So I've got y squared. I have no remainder. So no y's go on underneath the radical. So there's my answer. So does anybody not understand what I'm saying there? So you're going to break the number down just like we were doing. And then the letters, you just divide the exponent by 2 if it's a square root, 3 if it's a cube root. And we'll do something with cubes and stuff.
I feel like the takes are above mine.
Is-
I can feel it. Like it's like pushing up here.
That's what I'm saying.
What?
Why did you put it
Okay? Because sometimes you'll have numbers already outside the square root.
Do you just keep that number?
Yeah, so like because I go ahead and make my equal sign. Alright, so I'm going to have a -2 out front of the square root already. So then whatever I break down and pull out of 48, I'm just going to multiply times -2. Yeah, I can break that down. Y'all try that for just a second, see if y'all can do it.
So you leave it outside?
And see. If I break down the 48, alright, 8 and 6. And I told you 8 is 3 2s, right?
Yes. Oh, you did.
And then I've got 6 is 3 times 2. So I have one pair of 2s there. And then I have another pair of 2s there. And then I have a 3 left over. So I have 2 pairs of 2, so I can put both of them out here. Multiply. It's not 22, so I can multiply. Then whatever's left over stays inside the square root. If I don't have something to pair it up with, it has to stay under the square root sign. You don't get to come out of the square root sign unless you have a friend. It has no friend, so it has to stay under there.
It's lonely.
I have a question.
You gotta, or you know, you gotta be a couple to come outside the square root sign.
I think you messed up. Because under 8, it's not 2 times 2, it'd be 2 times 4, wouldn't it?
Yes, and then 2 times, and then 4 is what?
2 times 2.
So 2 times 2 times 2 is.
But wouldn't since the 4 be left over after that when you put the 4 into there too?
No, because I can break the 4 down again. I've got to break down everything as far as I can.
Oh, they probably did.
But 8 equals 2 times 2 times 2. That's what that means. You got to break down 4 again. Yes.
Instead of doing that, I just did the 16 times 3, and then 60 got me 4 for 3.
That's fine. That's fine.
Because I know my perfect square. So
That's fine. That's fine. Because then you got 4 times -2 out here. That's fine. Yeah, that's fine. You're fine that way. Just this works all the time, and some people don't see that all the time. So this works. Then sometimes people don't see that. All right. So then with the letters, it's a square root. So I divide 8 to the third. So I divide 3 by 2. How many times will 2 go into 3? 1 time.
B is the same.
And then I have a remainder of what?
1.
So I divide 3 by 2, and it goes in there 1 time, so I have 1A out here. Right? And then I have 1A left over because my remainder is 1, so it goes on the inside. And that works the same way. If I wanted to split that up into A times A times A, I have 1 pair of A's, so I pull 1A outside. Have 1A left over, so it goes on the inside. But that way, you don't even have to do that. You can just divide. So B to the 4th, 4 divided by B squared. C is just C. And there's not. So I don't have anything else on the inside?
I have a question.
Yes.
At the end, do you have to put it in order from largest to number?
No, normally the number goes in front, and then
No, I'm saying like
the letters.
alphabetical order or like which one?
People normally put them in alphabetical order. Which we probably need to multiply these out. So that's -8. You probably need to multiply that out. If you did if you got this right and then you accidentally said 2 times 2 times 2 was 6 or something, I might take off half a point or something like that. Because you did all the math right, you did the math that I'm worried about right. You just messed up on your multiplying. Like if so I want you to try, a cube root has a 3 right there. That tells you it's a cube root, in case you hadn't seen one before. This number's still on the outside. So instead of finding pairs of 2, you're going to find, I just told you.
What do you mean pairs of 3s?
Instead of pairs of 2,
Like dividing it?
like back here, I tried to find pairs of 2 here and here.
So you're trying to find pairs of 3.
In this one, you're going to try to find pairs of 3 numbers. Or sets of 3 numbers. It's not really a pair.
It's not like a cube.
Do what? This tells you it's a cube root. That's a symbol in math. It's just, no. If you can't find a pair of 3, then it's got to just stay under there the way it is. If it doesn't have a number like right here, it's understood to be a square root. Just like if I had an exponent of 1, x to the first, I don't have to write the 1. Square roots don't have to write the 2 there. But if it's a 3, then you'll write the cube root. Yes.
What about the number 81? You still get that as it is, or do you get 3 pairs?
You have to break it down into pairs of 3. I can't write 9 because we're not finding the square root. So this is not going to be 9 because it's not the square root. I got to find a pair. I got to find something times something times something that gives me.
Like on the exponents, do you have to divide those by 3 too?
Yes. So the exponents, instead of dividing by 2, you'll divide by 3.
Wait. Oh, this is difficult.
Okay, would you divide the outside number?
Do what?
too?
Alright. This is up here because some of you are confused.
I can do the letters.
Let's start with. Alright, let's go. Because we've only got one more. After this one, we've only got one more example. Break 81 down at 9 and 9, and then that's 3, 3, 3, 3. Alright, now look, it's a cube root. Hold on, I'm not. This is where you're struggling at. Instead, it's a cube root. Alright, so this 3's right here, not a 2. It's under. There's nothing. If there's nothing there, we assume it's 2. Square root, we use square root. Alright. But there's not. There's a 3 there. So instead of getting a pair, I need to find a group of 3.
Is that all that? Okay.
Well, I've got this -4 out there. I have one group of 3. So I pull 1 3 out. Alright? I have one group of 3, so I pull 1 3 out. So it works the same way as the square root. You're just trying to find a group of 3. So this leftover number still goes on the inside. So then with the x, I just take 6. Instead of dividing it by 2, I divide it by 3. 6 divided by 3 is, so it's x squared. Then y divided by, or 7 divided by 3. Yeah, with 1 left over.
Oh,
So that's negative.
oh, that was a 7 and not a 2. Can't read. Sorry.
Okay, I got you.
My 7s have lines. If this would have been a 2, can I divide 2 by 3?
No, you just
So I just would have just put the y squared up under there.
That's what I did.
Okay. So, does anybody have any questions? Do you have a question now?
I'm not right now, but I'm fine.
Okay. We've got one more example to do. And then we'll be done for today. I told you, we could have done half these yesterday, but we spent most of the time doing the trig stuff. So we're going to do this as a 5th root.
Are you for real?
No,
These were for real, man.
I can do the letters.
What is that? 3, 4?
Yep.
4.
This is
Wait, is that a Z?
3 pieces of paper.
Yep. That's a Z.
Z to the what?
41.
40.
Is 5 as high as it goes?
Do what?
Is 5 as high as it goes?
It could go up to whatever.
Well, I hope they don't go up to
I think 6 is the highest that's on your homework. If there is a 6. I don't remember.
homework on the weekend.
No.
He done said that the first and school Friday was a Friday.
I said I would try to make Friday your free day.
Well, same.
Because we've only got a couple minutes.
No, man, I was right.
Alright, so 28 is 64 and 2, and then that's 8 and 8.
Oh, I didn't. I probably didn't.
Oh, yeah.
And then I can split 8 into 3 2s and 3 more 2s. Alright, so that's 7 2s. Alright, 128 is a power of 2, it's 2 to the 7.
So you're going to find
Alright, I need a group of 5 before I can pull it out. So I've got -7. Have one group of 5 so I can pull out 1 2.
Oh. Yeah, and then you'd have
Alright, I've got 1 2 2s left over. So what am I going to have underneath? 4. Because anything I have left over I have to multiply and put it back under the radical. Alright, then I got to divide 10 by 5 instead of. So, alright, then y, 34 divided by 5. 6, and then y4 goes underneath. And then z.
C to the 8, and then C. Just C.
Alright. And then you can do this, other than negative, you can change that to -14. Yeah.